coefficient and a root. It's called mixed because it's got those two pieces. So an example could be 2 root 10. 2 root 10. Another example could be negative 6 times the cube root of 5. Totally making that up out of my head. Negative 6 times the cube root of 5. It's called mixed because it's got two pieces. It's got a coefficient and it got a radical. Entire radical, a number that only has a radical or a root. So an example could be the square root of 45. The fourth root of 68. And generally, these are not considered simplified. And so that's all I'm going to show you today is how to take something, for example, like root 45 and simplify it. So what we need is this multiplication property of radicals. That says if I have the nth root, so could be a squared, could be a cube, could be a fourth, so we just put n for generally any root, of a times b. I can split those up and say that that's the nth root of a times the nth root of b. That's the multiplication property of radicals. Nth root of a times b is the nth root of a times the nth root of b. If that's just too abstract for the left brains, here's an example with actual numbers. For example, if I have the square root of 2x, I can just split those up and say that's the exact same thing as the root of 2 times the root of x. That's the multiplication property of radicals. It just means I can split them up and give them their own radical. Still with me so far? Okay. This is going to be the key to simplifying, so let's look at some common questions. An example will say, simplify the root of 48. Now, to you, that probably looks simple, like what else can I do? To a mathematician, that is not simplified. Just like to regular people, x times x, no big deal. To a mathematician, we would never write xx. What would we write it as? X squared. So that, to a mathematician, is not simplified, even though to you, because you're new with radicals, maybe it looks simplified. Do you want an example first or the method first? I know what you're going to say, but I'll ask you anyway. Method first. Step number 1. Prime factor the radicand. Prime factor the radicand. What? Prime factoring? What the heck is that? Didn't we just do that last unit? What, are you saying unit 4 is connected to unit 3? Crazy talk. That's why we learned prime factoring. This is another application of it, is to simplify radicals. Step number 2. Split any prime factors with even exponents. Split any prime factors with even exponents from those without even exponents. No, I don't like without. From those with odd exponents. That would be odd. Yeah, I know, but that's why I was like, nah, I don't like that, and I went back. Use the multiplication property of radicals. And I'll explain what that means when we do an example. Square root. Ooh, I don't want to use square because it might not be squared. Take the root of the even exponents. Take the root of the even exponents. Leave the other root alone. And probably till you see an example, this method probably doesn't mean much. And we need some paper. Where is your paper? Keep coming to steal my paper. Where is your paper? Set a reminder in your phone. Okay, so keep the method right beside you because we're going to refer step by step. Step 1 is prime factor, just like we did in grade 9, just like we did in unit 3. Again, if you want to do it horizontally, that's fine. I like to do it vertically, whatever, doesn't matter. Give me two numbers that multiply to give 48. 2 and 24. Are either of those prime? 2. Two numbers that multiply to give us 24. Sorry, I heard a couple things there. 2 and 12. Either of those prime? Two numbers that multiply to give us 12. Either of those prime? Okay, and the next one. And so let's just group them. How many 2's do we have? And how many 3's? Ooh, what? Oh, that was your alarm for the ice. Gotcha. It's like a little Tinkerbell. I like that. So all I'm going to do, instead of writing 48, I'm going to write the prime factorization, which is 2 to the 4 times 3. Okay, so I've split the even exponent from that 3, just writing them separately. The next step is where I'm going to use that multiplication property of radicals, which just says I can split these up and give them their own radical. So I'm going to just split them and say it's radical 2 to the 4 and radical of 3. This one is a perfect square, so I'm going to evaluate it. So if I have 2 times 2 times 2 times 2, and I take the square root, why you're all looking at me like that? Did you not do these last year? Okay, so the trick is when you have exponents in your square rooting, you divide the exponent by 2 if it's a square root. You would divide by 3 if it's a cube root. You would divide by 4 if it's a fourth root. So 2 to the 4 when you square root becomes 2 to the 2. Okay, so I'll just make a note if you haven't seen that before. It comes from 4 divided by 2. And I'm going to leave that other guy alone, not touching him, just leaving him as root 3. And the last step, I'm just going to finish the simplifying. I wouldn't leave something as 2 to the 2. How would we write the number 2 to the 2? 4. There's simplifying a radical. Now, I know to you this is crazy talk, that this seems more simple than this. You just have to trust me. To a mathematician, this is pretty. This is really ugly and nasty. This, really pretty. Grab your calculator and calculate for me what's the approximate decimal value of root 48. And we've already practiced estimating, so we could, but I'll save you the work. So tell me root 48, approximately how much? An offer? Just root of 48, yeah. 6.9. Even or a whole bunch of other stuff? A whole bunch of other stuff. 6 point, give me a bunch. 6.928203233. Confirm all that? Yeah. Okay. Now I want you to calculate me 4 times the root of 3. So you're going to put 4 and then times, then root 3 and hit equals. It's the exact same thing. We haven't changed the value. We've just changed what it looks like. Again, to a mathematician, pretty, nasty, and ugly. Pretty, nasty, and ugly. We prefer a mixed radical over an entire radical. We like mixed radicals better. Why? Well, next year I'll show you what we can do all this, but I can't tell you now. Because it takes a whole unit in grade 11. Questions so far? I'm going to put a line because I'm going to show you another way to do it, and if you like this way better, great. If you don't, stick to the first method. I just always like to give you choices. Instead of prime factoring 48, what I'm going to do is just write all the different products of its factors. So just like when we did product sum factoring. So I could do 1 and 48, 2 and 24, 3 and
16.
Offer of 16. 4 and 12, 5, no, 6 and 8, 7, no, and now we're done because we've got the 8. Circle the group that has the largest perfect square number. Circle the group that has the largest perfect square number. So 1, for example, is a perfect square, but is there a group that has a bigger perfect square number? Which group? 3 and 16 is the group that has the largest perfect square. Remember 2 days ago we memorized the perfect squares 1 through 10. So we're looking for 1, 9, 16, 25, etc., etc. You still with me? Okay. So all I'm going to do is I'm going to take root 48 and I'm going to write it instead as the perfect square first and then the 3. So I'm going to write it as 16 times 3. Then I'm going to use that multiplication property of radicals that says if I'm multiplying two things under the radical, I can split it up. Rob, put it away, please. So I'm just going to split this into root 16 times root of 3, because that's the multiplication property of radicals. This one is a perfect square, so I can just evaluate it. What's the square root of 16? 4. And I'm just going to leave the piece that I can't evaluate, 3. Take a look at the two answers. Exactly the same. This is called prime factoring method. This is called perfect square method. Prime factoring method, perfect square method, whichever one you like better. Who's liking the prime factoring? Okay, who's liking perfect square? That was 4 hands out of everyone. Who likes the first one better? Who likes the second one better? Okay, completely up to you. As we go through examples, I'll show you both, and then after we go through, I'll just pick one. Example number 2. This is all we're doing, by the way. It's just simplifying radicals today. Square root of 24, prime factor. Two numbers that multiply to give me 24. 2 and 12. Any of those prime? Two numbers that multiply to give me 12. Any of those prime? Two numbers that multiply to give me 4. Any of those prime? Hey, count them up. How many 2's do I have? And what's left over? Now I'm going to be a little bit sneaky here. I know eventually I want even exponents, so I'm actually going to split up this 2. I'm going to write this as 2 to the 2 times 2 to the 1 that I don't need, and then I'm going to write that 3. So all I did was take that exponent of 3 and just split it into 2 to the 2 and 2 to the 1. Still with me? Okay, let's go back over here then. This now becomes the root of 2 squared times 2 times 3. The multiplication property of radicals says if I'm multiplying things under that radical, I can just split them up and give them all their own radical. So this becomes the root of 2 squared times the root of 2 times the root of 3. This is the one I can evaluate. What is the square root of 2 squared? Remember, all we do is take the exponent, divide by 2. 2. I'm going to leave these other ones, but what I'm going to do is just multiply them back together. So I can say that the root of 2 times the root of 3, if I want to simplify that, is equal to the root of 6. There's root 24 simplified. Root 24 and 2 times root 6, if we put them onto our calculator, are the exact same number. I haven't changed what it's equal to. I've just changed what it looks like. Why? Because mathematicians like this better. Why? I'll tell you in grade 11. If you like the other method better, factors of 24, 1 and 24, 2 and 2 and 3 and 4 and 5 and, so we're done? Which one is the highest perfect square? Four and 6 is the highest perfect square. So I'm going to take root 24 and just write it as the perfect square followed by the other number. The multiplication property of radicals says I can split these up. I'm just going to evaluate the first one. What is the square root of 4? And then I'm just going to leave what's behind it. Take a look. Exact same answer. 2 different methods. Pick whatever method you like better. Show me your thumb. How are you feeling on this? I'm getting it. Maybe not perfect, but I'm getting it. I'm not getting it. Awesome. Let's do a cube. $256. 2 and 120. I'm just writing down what you're saying, by the way. So. Confirm there's 8 of them? Okay. Now I'm going to be a little bit sneaky because I know I need a cube root here. So what I want in here is groups of 3. So how many groups of 3 are there in 8? 2. So what I'm going to do is split this into 2 to the 6 and the leftover, which is 2 to the 2. Why did I choose to split this with a 6? Because 6 is divisible by 3. And why do I care that 6 is divisible by 3? Because it's a cube root. Okay? Last time I didn't care because it was a square root, so I just cared about even numbers. Now I care what's divisible by 3. Okay, so I'm going to say this is the cube root of 2 to the 6 times the leftover, which is 2 to the 2. The multiplication property of radicals says if I'm multiplying 2 things under the radical, I can just split them up and give them their own radical. So this is going to be the cube root of 2 to the 6 times the cube root of 2 squared. This one I can evaluate evenly. What happens to the exponent when I square root or cube root something? We divide by it. So 6 divided by 3 leaves me with 2, and I'll just make a note. That comes from 6 divided by 3. I can't divide evenly this guy, so I'm just going to leave him exactly the way he looks. And last thing, I'm just going to evaluate those exponents because I wouldn't leave 2 to the 2. What would I write instead of 2 to the 2? 4 And then under the cube root, I have 4. Let's just prove on our calculator. Calculate for me the cube root of 256. Cube root of 256. Confirm. Okay, calculate 4 times the cube root of 4. So you're going to hit 4 times, then you know where the cube root button is from yesterday, 4 equals. Same thing. Again, I haven't changed the value, I've just changed what it looks like, because from a mathematician point of view, I like 4 as a radicand way better than I like 256. And where we're going in grade 11 is we're going to add radicals and subtract them and multiply them and divide them and solve them and do all this great stuff, and they need to be simplified in order to do that. I haven't changed the value, I've just changed what it looks like. Why? Because I like this better. If you like the other method, what you would need to do is list all the factors of 256, and then instead of looking for the largest perfect square, we would look for the largest perfect cube, which we've memorized that list from 2 days ago. Let's do a 4th root. Okay, prime factor 160. Please don't do 2. Let's do a bigger number so we don't have to do as many branches of the tree. 160. Go for the obvious. 10 times 16. Again, you can do 2. I'm just trying to make this go faster. Five and 2, I heard someone say. How many 2s? And? Now with the square root, I was concerned about even numbers. With a cube root, I was concerned about groups of 3. What do you think I'm going to care about now? Groups of 4. So I want to break this 2 to the 5 into 2 to the 4. And what will be left over? 2 to the 1, and then I still got that 5 hanging around there. Again, just to repeat, why did I care about this 4 and I didn't care about 4 before? Because it's a 4th root that I'm dealing with. If I was dealing with a cube root, I would have split it into groups of 3. I just chose 4 because it's a 4th root. Okay, so I'm just taking the 160 and splitting it into 2 to the 4 times 2 times 5. I'll back up. If you like the second method better, you're going to write out all the factors, and then you're going to pick the factor that has the largest perfect. So a square root, we did perfect squares. A cube root, we did perfect cubes. A 4th root, we do perfect fourths, they're called. And we memorize those along the table on Monday. What do I do now? So this is the 4th time we're doing it. Same step every time. What do I do now? No, I need to split them, right? So that is called the multiplication property of radicals. So it just says I can split them up. The first one is the one I can evaluate, and what happens with the exponents and that root, and what happens when I go to simplify it. So what is the 4th root of, or what is the 4th root of 2 to the 4? 2 to the 1. So I'm just going to put the imaginary 1 so people can see what we did there. Why is it 1? Where did that come from? 4 divided by 4. So it's the exponent divided by the index. I'll repeat that again if you're a wordy person. The exponent divided by the index. Do I need to write that 1? No, I'm just putting it so when you look back, we know what we came from. Then what I'm going to do is just group these two together. I don't like those two radicals hanging around, so I'm just going to multiply them using the multiplication property that says that can become the fourth root of 10. That's as hard as they're going to get. Find a friend or someone that looks friendly or really just anyone that breathes. And I'm going to give you about 5 minutes to do number 5 and 6 together, and then we'll talk. Okay, give me the factoring breakdown for root for 28. Yeah, just give it straight to the factoring. Times. What do we do? But it doesn't what? It doesn't work. So what do we do? What does it tell you about this if we can't do anything here? It's already simplified. If your gut was telling you to stop, then stop. So if your gut was saying, wait, something, I can't do anything, then don't try to force something out of it. It's already simplified. Okay, give me straight the factoring. 5 squared times 5. Why did we choose to break it up like that? Why didn't we leave it as 5 cubed? Because we want to get an even exponent out of it. What is the property that I'm about to use to split this up? What's it called? Multiplication property of radicals. I keep repeating it because it's going to come up next year, and I want to make sure you've heard it and it makes sense when I say it next year. So I'm just breaking this up. What am I doing with it now that I've broken it up? Take the root of the first one. The root of 5 squared is 5. And what do I do with this root 5 hanging around there? Just tag them in the back. Who had that one? 5 root 5. Again, I know to you it doesn't look any more simple. You just need to trust me. Next year it needs to be like this for what we're going to do. Show me your thumb so far. Getting this? Okay. Good. I want to give you lots of time to work. Do you want to work in groups that I make up? Do you want to work in